Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at lowest common multiple, highest common factor and the prime numbers. We're going to start by counting in twos. So we can all count in ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When I was young, I used to read off the house numbers walking down the street with my dad, and so I would be counting in twos. I would go 2, 4, 6, 8, 10, 12, certainly on one side of the street. Obviously the other side of the street is the odd numbers, but on one side of the street we get the even numbers. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. These numbers are all the multiples of 2. They're the even numbers. So they're all the numbers we get when we times 2 by another number. So for example, 14 is 2 times 7. We can also count in threes, which will give us all the multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Count in fours. Counting in fives has a very particular rhythm, so it goes 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. It's like a march. You could march along to that rhythm, couldn't you? One foot, the other foot, 55, 60, 65, 70. Multiples of 6, counting sixes, counting sevens, counting eights, counting nines. Little note here, when we look at all the multiples of 9, in each case, when you add the digits are add up to 9, which is a really pretty thing. Then the multiples of 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So what we say is, we would say 18 is a multiple of 6, 6 is a factor of 18. 6 goes into 18, exactly. 18 is 3 times 6, so it's a multiple. Okay. We can also look at these visually and the patterns they make on the grid. So here are all the numbers from 1 to 100, and I've just shaded in all of the multiples of 2. And as we can see, there are 5 very clear rows going down. This is a bit like a lawn that's been mowed really, really well with a lawnmower. You get these very clear rows going down. Multiples of 3 create these pretty diagonals coming across from the top right to the bottom left, or up from the bottom left to the top right, depending on how you look at it. The multiples of 4, so these are actually, every multiple of 4 is also a multiple of 2. But not every multiple of 2 is a multiple of 4. So for instance, 6 is a multiple of 2. It's 3 times 2. It's not a multiple of 4. But 8 is a multiple of 4, 4 times 2, and it's also a multiple of 2. So we say the multiples of 4 are actually a subset of the multiples of 2. These are the multiples of 4. Multiples of 5 make a very similar pattern. And isn't it interesting? There are 2 lines going down which actually almost match the rhythm of 5, 10, 15, 20, 25, 30, 35, 40. When I was young, I used to draw these grids and colour things in and look at these patterns. It fascinated me. It still does fascinate me. Multiples of 6 go across diagonal, top left to bottom right, these sort of flat diagonals. Multiples of 7 have a more complicated pattern, but we can still see patterns in there, and we can still see diagonals, actually steep diagonals, top left to bottom right, or shallow diagonals, top right to bottom left. The multiples of 8 also have these different patterns. Multiples of 9, very clear. Multiples of 10, even clearer. Just a single line going down. And again, every multiple of 10 is a multiple of 5, but not every multiple of 5 is a multiple of 10. So basically, with 10, you've got this single line going down, whereas with 5, you had 2 lines going down. Now we're going to look at the prime numbers. So the prime numbers are what is left when you take all the other multiples away. They're what is left. They're basically the numbers which are only multiples of themselves. So you've taken 4 away because it's a multiple of 2. You've taken 9 away because it's a multiple of 3. You've taken 15 away because it's a multiple of 5 and 3. What you got left here is the numbers that are only multiples of themselves. 29, nothing goes into it. 37, nothing goes into it. 97, nothing goes into it except 97. And their shape is not as predictable. In fact, there are people who've devoted their whole careers to understanding the pattern of the prime numbers. So mathematicians who have devoted their whole careers to it, and the mysteries of the prime numbers are incredibly difficult and deep and profound. We know a number of things. We know that there is no biggest prime number, so we can prove, and the more enthusiastic students might want to prove this and write in the comments or have a think about this or drop me a line. How you prove that the prime numbers go on forever. There are an infinite number of prime numbers. It's fascinating. It was proved thousands of years ago. It's not particularly easy, but it is doable. It can be done. And so we know there is no biggest prime number. We also know that as the numbers get bigger, we get fewer prime numbers. So just on this diagram, we can see there are 4 numbers between 1 and 10, and only 1 prime number between 91 and 100. So we're getting fewer. Basically, as you get bigger, there's more chance that you have a factor. So with 100, there's loads of chances of things having a factor, whereas with 5, you have fewer possibilities. But we know that prime numbers thin out as numbers get bigger, and we know that they go on forever. But exactly how quickly they thin out, now that becomes complicated stuff. Okay, now we're going to talk about lowest common multiple. The lowest common multiple is the smallest number that's a multiple of both numbers. So we're going to talk about the lowest common multiple of 4 and 6. This is the smallest number that's a multiple of 4 and of 6. So some of you, this may just pop into your head. If not, it doesn't matter at all. It's absolutely fine. We're gonna work it out. Some of you, it may pop into your head. Some of you may want to pause the video to think about it. Some of you may just want to crack on. It's totally up to you. It's your video. I'm just here to help. So basically, how we're going to look at this, these are the multiples of 4, and these are the multiples of 6. And we're going to flick between them and look to see if there's some squares that are shaded in on both diagrams. And what may be jumping out is if we look at the 12 square, that's shaded on both, and the 24, and the 36, and the 48. So these are the ones that are shaded. These are the ones that are in both diagrams. So what we see is these are the common multiples, and 12 is the least common multiple of 4 and 6. So 3 times 4 is 12, 6 times 2 is 12. So it's a common multiple and it's the least. There are no smaller ones. Right. We're going to practice that, and we're going to look at some examples of this, but before that we're going to look at highest common factor. The highest common factor is the largest number that is a factor of both numbers. So for example, let's look at the highest common factor of 12 and 20. What's the biggest number that goes into 12 and 20? Again, it may have come to you. You may want to pause the video and think. You may just want to crack on. It is completely your choice. Here's how we're going to look at it visually. So these are all the multiples of 2. Now, we're going to ask, does 2 go into 12 and 20? And we can see that 12 and 20 are both highlighted. They're both shaded. So 2 does go into both 12 and 20, but we'll find out it's not the highest common factor, it's just a common factor. 3 is not a common factor, it doesn't go into 20, it goes into 12. 4 is also a common factor, it's a common factor of 12 and 20. And actually, we find out it is the highest common factor because 5 doesn't go into 12, 6 doesn't go into 20, 7 goes into neither, that's rubbish, 8 goes into neither, 9 goes into neither, 10 goes into 20, but not 12. So just flicking back, isn't it pretty all this stuff? 4 is the highest common factor. It's the biggest number that goes into 12 and 20. Now, prime factors. Prime factors are all of the factors that are also prime numbers. And the prime factors matter because they're like the ingredients that go into the recipe that makes the number. So again, we're going to look at some examples. So the number 30, the ingredients are 2, 3 and 5. And we make 30 out of 2, 3 and 5 by timesing 2, 3 and 5 together. So 2 times 3 is 6, times 5 is 30. 31 is its own ingredient. It's its own prime factor because it's prime. So it has one prime factor, which is 31. 32 has 5 ingredients, and those ingredients are 2, 2, 2, 2, and 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the recipe here is just made up of two. It's like my old spaghetti sauce that was made of tomatoes and tomatoes and tomatoes and tomatoes and tomatoes. Kids used to love it until they found out the secret recipe. But 32 is like that. It's just made up of 2 times 2 times 2 times 2 times 2. And we have to count all the 2's, otherwise it doesn't work properly. So we've got to count how many times a prime factor occurs. 33, it's 3 times 11, and 34, it's 2 times 17. So what jumps out to me here is, when you go up by a number, actually the prime factors change enormously. 31 has 1 prime factor, and then 32 has 5, even though they're all the same. Then 33 has 2, so it's jumping around as we're going up. It's really interesting how that happens. Now, this is important because this gives us a way to calculate the lowest common multiple. So the lowest common multiple is made up of the prime factors that are in either of the numbers. So the recipe for the lowest common multiple is made up from prime factors that are in the recipes for either of the numbers. So let's just look at that. So we looked at the lowest common multiple of 4 and 6, and we found out that it was 12. Now let's do it from the recipe. So 4 is 2 times 2, that's the recipe. 6 is 2 times 3. So to make the recipe for the lowest common multiple, we have to take these two 2's from 4 and then this 3 from 6. So we don't need to take the 2 from 6 because we've already got that. We've already got 2 2's from 4. But we need to take the 3 from 6 because we haven't got that from the 4. So we get the 2 and the 2 from 4 and the 3 from the 6. And then we go 2 times 2 times 3 is 12. And we see that is the lowest common multiple. That is 12. We can also create a recipe for the highest common factor from the prime factors of the numbers. But this time we take the prime factors that are in both numbers, not the ones that are in either. So we looked at 12 and 20. So with 12, the ingredients are 2 times 2 and 3. 2 times 2 is 4 times 3 is 12. Those are the ingredients. With 20, the ingredients are 2 times 2 times 5. To get to the highest common factor, we need to take the ingredients that are in both 12 and 20. So they are only 2 times 2. So 2 times 2 is 4. This is the highest common factor. This is what you found. We found 2 was a common factor, but we found 4 was the highest common factor. So our method has worked again. We've taken the ingredients that are in both numbers. Now we're going to do some ourselves. So we're going to do 3 and 4. So I'm asking you the highest common factor and the lowest common multiple. Again, feel free to pause. I'm going to say this every time. Feel free to pause. Feel free to just know. Feel free just to let me tell you. It's totally up to you. So the highest common factor, so the only number that goes into 3 and 4 is 1. Because nothing else goes into both 3 and 4. So they have no other common factor. So the highest common factor is 1. The lowest common multiple is 12. And we actually get that by 3 times 4. So 3 times 4 is 12. And that gets us to the lowest common multiple. This does not always work. If we times the numbers together, we get a common multiple, but it's not always the lowest common multiple. In fact, it's only the lowest common multiple in a case in which the numbers are co-prime. Co-prime means you have a highest common factor of 1. So don't feel you have to understand that. That's one for the more advanced students, but it's just one to think about in the future. Okay, next. 6 and 8. What's the highest common factor? What's the lowest common multiple? Again, I'm going to give you a pause. Okay. The highest common factor of 6 and 8 is 2. So 2 is a common factor, and there are no bigger ones. Times them together, 6 and 8, we get 48, we get a common multiple, but there is a lower common multiple. We can go lower. 24. 24 is 4 times 6. 24 is 3 times 8, so that's the lowest common multiple. 2 is the highest common factor. 24 is the lowest common multiple. Two slightly bigger numbers here. Might be a bit more of a challenge. So 32 and 48. What is the highest common factor of 32 and 48? So you might want to break this down into prime factors and build a recipe using the prime factors. You might want to just draw a picture. You might just want to feel it and sense it and let it pop into your brain. I'm all for that. Or you might want to wait for me to tell you. So the highest common factor of 32 and 48 is 16. 2 times 16 is 32. 3 times 16 is 48. So 16 is a common factor of 32 and 48, and it is the biggest. There are no bigger ones. The lowest common multiple is 96. So 3 32s are 96. 2 48s are 96. It is a common multiple. It is the very lowest. There is nothing lower. Right. Now, 10 and 15. Slightly lower numbers here. Okay. So highest common factor, lowest common multiple. Again, have a little think. Okay. The highest common factor is 5. 5 goes into 10. 5 goes into 15. The lowest common multiple is 30. 3 times 10 is 30. 2 times 15 are 30. Here they are. At this point, well, there's something to point out, which is 5 times 30 is 150. And 10 times 15 is 150. So when we multiply the numbers, we get the same number as when we multiply the highest common factor times the lowest common multiple. Isn't that interesting? I wonder if it happens with other numbers. This is sort of just exploring. 2 times 24 is 48. 6 times 8 is 48. Oh, this is fascinating. 3 times 4 is 12. 1 times 12 is 12. There's another one. 32 times 48 is something. 16 times 96 is something. I'll let you do that in your own time. Are they the same number? And I would ask you more generally, is it true that if you times the numbers together, you get the same number as if you times their highest common factor times their lowest common multiple? Is this true? If so, can you prove it? Please write in the comments what you think of this and give us your reflections. Just to be clear, don't feel pressure to do all of this. Don't feel pressure to know all of this. That's not what it's meant to be about. It's meant to be fun. It's meant to be stimulating ideas. You might spend 3 years thinking about this in the background while you're walking the dog, while you're doing other things, and it might pop into your head, and that will be a great achievement. There's no pressure here. It's just about growth. It's just about enjoying mathematics. It's just about exploring things, really. That's the general idea. So, in summary, if you like this video, please press like. In fact, even if you didn't really like it, please press like. It all helps. Please subscribe to the channel. I'll be sending you more. If you're at home during coronavirus, or if you're even a school teacher, or whoever you are, or even if you're just here for fun, I'm going to be sending more. Please hit the notification bell so that you know. Most of all, I hope you enjoy your mathematics. It's great to learn. It helps us do other things. It's also meant to be fun. And I really, really look forward to seeing you next time. It's great that you could come.